Hello students, welcome back to AriserTalent. I am Arpita Sharma, your maths teacher. Student, we are discussing this chapter. The chapter's name is what? Circles, right? So starting with writing the name of the chapter, which is circles. Now what we have gone through, the basic definitions, okay? Some basic definition we have gone through. Then we have studied the circle's center, its radius, its circumference, sector, minor and major, then segment, minor and major, then arcs. Okay, so we have gone through the definition part. After that, we have covered some theorems. Okay, and which kind of theorem? We talked about chord, and in the circle, we talked about two chords. This is one and this is second, and there is some angle subtended by that, and we proved that if these two chords are equal, then these angles will be equal. Now the converse of it, we have to prove that these two angles are equal, then these two chords will also be equal. Okay, so this was what we were studying. Our topic was angles subtended by a chord at a point. We discovered about many of the angles that are made by the two chords and the center and the point somewhere on the circle, on the circumference of circle. Okay, now we have proved this theorem: equal chords of a circle subtend equal angles at the center. Okay, this one we have proved, right, about the equal angles. We have proved about the equal angles. Now, equal angles are given. The converse of it. Converse of this is if the angles subtended by the chords of a circle at the center are equal. Now, that what we have proved is given to us. Right? And then the chords are equal. Chords were equal given, and then we have to prove the angle subtended by the chord equal. Now, angle subtended by the chord given equal, and we have to prove the chords are equal. Okay? Okay. So, how we are going to prove this? Let's start this by making a circle here. Okay? So, circle. Will this circle work for you? No. We have standards for circle, no? Circle should look like a circle. Now it's looking like a circle. Now this is it. Okay, this is a circle. This is a complete circle. Okay, you hope so. And it's saying that the angle subtended by chords of a circle. Chords of a circle, so we are taking two chords. So we liked A, B and PQ name. So A and B is here. So 2 points AB here and 2 points PQ here. I somehow match these 2 points. Okay, now I will meet this center O to A and B and P, O and Q, O. Okay. Now it's saying that the angle subtended by the chord of a circle at the center. So these are the angle at the center, and it's saying that this is equal. Okay. Now it's saying us to prove something. So let's find out how to prove this. So first, how we'll start these theorem questions? How we'll prove theorem? What are the steps? Step 1, we have to write what is given to us, guys. So given. So we will write the given things first. Okay. So the given thing is here that the angles subtended by the chords are equal. So angles subtended by chord are A, O, B and P, O, Q. So given angle A, O, B is equals to angle P, O, Q, right students? Okay, then we have to prove what? We have to prove, not to prove, what is this? We have to prove. So we have to prove that the chords are equal. Now AB is one chord and PQ is another chord. So we have to prove that AB is equals to PQ. Simple. Simple. Okay. Now proof. Okay. So for proof we will be having this triangle and this triangle. So names of these two triangles are in triangle AOB and POQ. You have this information. Okay, write it. Angle AOB is equals to angle POQ, and simply it's given. It's given. Given na? Okay, so write it. Now, here is this side AO, which is equals to OP, and this side OB is equals to OQ. Okay, this is the angle, and these two are radius. So sides. So by this side angle, or you can say that side angle side congruency okay, what will say that triangle AOB is congruent to this triangle POQ. And that means AB will be equals to PQ. Understood? Right. So this side equals to this side. Isn't it very simple, guys? Simple? Okay. Now note it. We have in this case used the same concept. Okay, noted. Okay. Right? Now, we are having this, recall that two circles are congruent if they have the same radii. Prove that the equal chords of congruent circles subtend equal angles at their center. So first thing first, recall that two circles are congruent if they have the same radii. We have talked about circles in our small classes. Okay, so we know that this circle. Likewise, we know the congruency of triangle. Okay, we also know that the two circles are congruent if their radius is same. That means if R1 equals to R2 and this circle's name is C1 and this circle's name is C2, then this C1 will be congruent to C2 circle if their radius is same. That means R1 is equals to R2. Okay, if R1 equals to R2, then this circle will congruent to this circle. That means if you make 10 circles of same radii, then these all 10 circles will be congruent to each other. Radius same, that means they are congruent. That's simple as that. Okay. If they are not having if they are not having equal radius, that means they cannot be equal. That means they cannot be what? They cannot be congruent. Okay. Right. Noted? So concept clear about the equal radii? Okay. Prove that the equal chords of congruent circles. Now it's talking about congruent circles. So okay, draw the circle here. Draw a circle here too. They are saying that these two circles are what? Congruent. These two circles are what? Congruent, and we have talked that if they are congruent circles, that means they need to have equal radii. That means if this is R1, this is R2, then these two are equal. That means I can say this is R and this is R also. But this circle is different, C1, and this circle is different, C2. But these two are congruent. It's saying that equal chords of congruent circles. Equal chord. So equal chord, that means I am having this AB here. I am having this PQ here. Equal chords, that means this AB is equals to this PQ. This AB is equals to this PQ, and also circle C1 is congruent to circle C2. These two informations are given. Equal chords of congruent circles subtend equal angles at their centers. Equal angles at their centers. That means they are talking about the angles at their center. Now this chord will have the angle at its center by constructing these two lines. Let's suppose this is O, and let's suppose it is O dash. The center is O dash. So if I meet this, I'll be having an angle here, an angle here. Now the examiner is asking us to prove that this angle is equal to this angle. These two angles are equal. If these two circles are congruent, that means these two are having same radii, same radius. Okay. So how will we going to prove that? Simple technique. First we will write to prove. What to prove? Simply we have to prove that angle AOB is equals to angle PO dash Q. Alright, okay. And we have given these two informations, that AB equals to PQ and circle C1 is equals to circle C2. Two informations are given. I am talking about the proof now. Okay. So if I talk about triangle, in triangle AOB and triangle PO dash Q, these two are triangles. Now in these two triangles, what I found is that this AO is equals to PO dash. Why? And this OB equals to O dash Q. Why? Because radius or radii of congruent circles are equal. Simple. That means we are having two sides equal here. Okay. These two sides are equal, right? And AB, okay, AB is equals to PQ. Now this is what? This is you have given that the chords of them, the congruent triangle, are equal. So this is given. Okay. Now what else? You are having this side, side and side. So by side, side, side congruency. Which congruency, students? Side, side, side. So side, side, side congruency by side, side, side congruency, this triangle AOB is congruent to this triangle PO dash Q. Okay. Now what we have to prove? We have to prove the angles. So okay, angle AOB, these are two equal congruent triangles. So angle AOB will be equals to what? Angle PO dash Q. Angle PO dash Q. Hence proved. Okay, so AO, PO dash, BO equals to OB equals to O dash Q, AB equals to PQ, SS is congruency, these two triangles equal, so angle will be equal, and that you have to prove angle AOB equals to PO dash Q. Understood? Now what you are waiting for? Note it. We'll move towards the next question afterwards. Noted? Okay. Look students, very easy now. How you can only use this trick that you will be finding two triangles, and you have what you have to do. All you have to do is provide by the information you are having, right? Use them and prove them congruent, and then you can find your result. Okay, you can prove whatever you asked about. Okay, so this is good chapter, right? Okay, the next is prove that if chords of congruent circles subtended equal angles at the center, then the chords are equal. Now what it's saying, again it's talking about the congruent circle, two congruent circles talking about. So again I have to make two circles here and here. Okay. I'm not thinking that this circle is going to be okay. So this is one. Okay, now this is good. Okay, now this is the second one. So the second one will be this. Okay, these two circles. Now the centers, let's suppose O and O dash. Okay, it's saying that two chords, if the chords of congruent circle, these are congruent circle, that means this is R and this is R. So radius will be same for both the cases, the C1 circle and the C2 circle. Okay, now if the chords of congruent circles, chords are there, one chord, second chord, you can draw this chord not necessarily here, but you can write draw it here also, here also, here also, anywhere you want to. Okay, and you are having this chord here. This chord's name is what? AB, and this chord's name is PQ. Okay, now chords of congruent circles subtend equal angles at their center. So this is given that these two angles they are making are equal. This is given. Then the chords are equal. Now you have to tell whether this PQ is equal to this AB. It is. So you have to prove it. Okay, right. So what we'll do, we'll write the information which is given, then we'll write what we have to prove, and then we will be writing the proof. So talking about given things, we have given C1 is congruent to C2. We have also given that this angle AOB is equals to angle PO dash Q. This is given. Okay, and we have to prove that AB equals to PQ. What I have told you, simply you have to prove that these two triangles are congruent. After the congruency, you have to just pick this from the congruent triangle. This is so simple trick. Okay, so do the same about the proof. Here I am having this AO equals to PO dash and this OB equals to this O dash Q. how these two are equal? Simply again I am telling you, these are the radii of congruent triangles. Congruent, not triangles but circles. Okay, circles. The first thing. So 2's are here. Now it is given that angle AOB is equals to angle PO dash Q. Given here. So by side angle side congruency, what will you find out? That this triangle, what? Triangle AOB is congruent to this triangle PO dash Q, right? And if they are triangle, these triangle are congruent, that means AB that will be equals to with PQ. Simple. Hence proved. Easy. Okay. So now you are going to copy this. Copy. Okay. This chapter circle is so very easy. You are going to do all the questions which are coming from this, because this is having very less concepts. If these few concepts are clear to you, you can do each and every question of it, right? Okay. So after that we are having this question. This theorem, right? The perpendicular from the center of the circle to a chord bisects the chord. What this theorem is saying? You are supposed to learn these theorems and the results. Why? Converse also. Why? Because these properties you are going to use in your questions. You have to use these properties in your questions to solve this. Like, if you are given with two circles, okay, this is 1, this is 2. Now you have given that this is R and this is also R. Now you are provided with the A, B, C and D, and this is O and this is O dash. Okay, and you have told that this is angle 56 degree and this is angle 56 degree, and this chord is equals to 26.5 centimeter. Then find the value of CD. Simply this is R equals to R. These two are congruent angles, not congruent triangles but congruent circles, because having same radii, that means this angle and this angle is the same, and also this chord will be equals to this chord. If these two are congruent circles and if you are having the same angle, then the chords will be the same that we have taught in the theorem. So that means we don't need to do any calculation, but we just have to find out that the value of this will be equals to this. So the simple answer, what will it be? 26.5 centimeter without blinking. That will be your answer. Okay, so you have to use such kind of theorems in your questions also. Okay, so you have to remember them. Okay, you just don't have to prove them, but you also have to remember them in order to solve questions. Sometimes it may look very tough question, but by a simple theorem, by a simple property or by a simple theorem, you can solve the entire question in just this. Okay, now what this question is, theorem is basically saying that if you are having the all is about a circle, so what we are going to need is a circle. Okay, is this a circle, like a circle, or do I need to reframe it? I have made 2 circles just before that, like actually circles in one go. Okay, this is my circle. Okay, now the perpendicular from the center of the circle to a chord, bisect the chord. It's saying that if you are having AB as your chord, now you will say, ma'am, why your chord always lie this side? Okay. Any chord you can take. Let's suppose this is A and this is B. You can say either to me that, ma'am, why is your this like this only? Can it be horizontal? Yes, it can be. Now maybe if your this AB is your chord, is trying to say that if I draw this perpendicular to here, okay, the perpendicular to the center of the circle. Okay, so from the center of the circle, this is the center of the circle, let it be O and the circle is C1 to the chord. This chord, so it is, let's suppose it's point P when it's this perpendicular is intersecting this chord AB. That's saying that in this situation, this OP will be perpendicular to this AB. How? How? No, it's not saying that. It's saying that if OP is perpendicular to, we will get back to that also, but after that, so if OP is perpendicular to AB, then AP is equals to PB. That this perpendicular basically divides this chord in 2 halves. This we have to prove in this theorem. Okay, so we will prove this theorem, but not in this lecture. As I always say you, I'll just left you with something to do in your spare time. Okay, so do that theorem and we will meet in next lecture. What you have to do, you know very well. You have to practice some questions, study hard and enjoy your life. Okay, bye bye, take care.